Number 1, Charlie drove 465 miles on 18.6 gallons of gas. The car averaged how many miles per gallon? This comes from lessons 3 and 25. So first, the information they gave us is that Charlie drives 465 miles on 18.6 gallons of gas. We want to know what his average is, how many miles per gallon, per 1 gallon. So all we have to do for this one is take our 465 miles and divide that by, or we could say per, 18.6 gallons, because we want to find out how many miles he goes on just 1 gallon. So 465 divided by 18.6, and that'll give you 25 miles per gallon. And that's your answer. Number 2, a bag contains green and yellow marbles in a ratio of 5 to 7. If one marble is drawn, what is the probability that the marble is not green? This is from lessons 29 and 32. So some important information here is the ratio is 5 to 7, and we want to know the probability that it's not green. So remember, probability is always what you want. So I'll just put want over the total amount. We don't want green, so not green over total. So we need to go back and figure out that it's what our total amount of marbles are and how many are green and how many are yellow. It says that the ratio is green to yellow and the ratio is 5 to 7. So remember, it's in the same order. So green is first and then yellow. So this 5 represents green, 7 represents yellow. So that means that there are 7 yellow marbles, and there's a total of, all we need to do is add our 5 and 7. There's a total of 12 marbles. So 7, we are using 7 because that's our yellow marbles, and that's what we want if we don't want green. And then this represents our total marbles. So our final answer is 7 over 12. That's the probability. Number 3, a triangle has sides 9 inches, 11 inches, and 14 inches. Is this triangle a right triangle? Justify your answer. This is from Investigation 2. So we always know if a triangle is a right triangle if its side lengths fit the Pythagorean theorem, which, if you recall, is a squared plus b squared equals c squared, and c representing our hypotenuse or our longest side. So even though this problem does not give us the picture of the triangle, I know that 14 inches would be our c squared because it's our longest side. And then it doesn't matter which one we put 9 and 11 into, if I put 9 into A or B or 11 into A or B. So I'm just going to go in order. Let's put them in Pythagorean theorem and see if this works. So I'll plug in 9 in for A and have 9 squared plus, for B squared, I'm going to put 11 squared equals 14 squared. 9 squared is 81 plus 11 squared is 121 equals 196. Now if I add up 81 plus 121, that gives me 202, which does not equal 196. So no, not a right triangle. And you can say because it does not work in the Pythagorean theorem. So not a right triangle. Solve this formula for h. V equals LWH from lesson 79. So this is one of those problems where we have only letters, no numbers. But we still solve it like we would an equation with numbers, where we do division, multiplication, addition, subtraction, whatever it is to move the numbers and variables around so we isolate whatever variable we're solving for. So in this case, we are solving for our h. So that means we need to get rid of this L and W and move it from one side, from the right side to the left side. So just like we would any other type of equation, we see that L, W, and H are all being multiplied together. So we need to do the opposite of multiplication, which is division. So I can divide both L and W from the right side all at once. So I'm going to divide by LW, because we know LW divided by LW is just 1, so those cancel each other out, which is exactly what we want. But then I have to divide the other side by LW. So on my right, I have H left, which is perfect because that's what I'm solving for. And over on the left, I just have to leave it as V over LW, because unlike other equations, there are no numbers in this one, so we can't reduce that any further. So that's your final answer. The amount of money the kids make varies directly with the number of popsicles they sell. When they sell 56 popsicles, they make $16.80. How much will they make if they sell 350 popsicles? So when you have varies directly, direct variation, you can easily just set up a proportion to solve these problems. So let's start with the information we're given. 56 popsicles, and they make $16.80. So I'm going to do popsicles on top over the money that they make on the bottom. And then I'm going to have my second proportion. They gave me 350 popsicles. So notice I put that in the numerator because the top is where I'm writing popsicles and the bottom is where I'm writing money. But we don't know how much they make for 350 popsicles, so that's what we're trying to figure out. So now we just solve this like a regular proportion where we use cross multiplication. So we do 56 times x is 56x equals 350 times $16.80 is $5,880. Now I want to divide both sides by 56 so that I get x equals 105. And remember, we're finding the money amount, so this is going to be $105. Number 6, marble costs $54 per square yard. How much does it cost per square foot? This is from lesson 64 and 72. So remember, anytime we're going from a square unit to another square unit, we're going to have to use 2 unit multipliers. So let's first start with what they've given us, $54 per square yard. So that's $54 per square yard. I'm going to write it as yards squared. And now I need to convert it to square foot. So I have to look at what unit multipliers I'm going to use. So I could either use 1 yard is the same as 3 feet, or 3 feet over 1 yard. However, since I want to cancel out this yard square, I need to make sure I use the unit multiplier with yards in the numerator so that I can cross cancel them. So I multiply by 1 yard over 3 feet. However, I have 2 yards here, and this will only cancel out one of them. So therefore, that's why I need to use 2 unit multipliers so that I can cancel out both of these yard squares. Now we just multiply across. So I have 54 times 1, which is 54, all over 3 times 3, which is 9, feet times feet, which is feet squared, and then reduce. So 54 divided by 9 will give me $6 per square foot. And that's your answer. Number 7, what is the perimeter of the base of this prism? This is from Investigation 2 and Lesson 20. So the base of the prism, remember that the base of any prism is always going to be the two sides that are parallel to each other and congruent. So as you can see, most people will probably think this, looking at it, is the base, that rectangle. But it's not, because notice there's not another side that's congruent to it and parallel to it. So let's erase that because that is not our base. Our base is actually this triangle. Because if you notice, there's a congruent triangle that is parallel to it. So those are your two bases. It almost looks like this prism was just kind of knocked over onto its side. So if we want to find the perimeter of the base, we just need to add up all the sides of these triangles. So 3 plus 4 plus 5 will give us 12 centimeters. And that's your final answer. Number 8 wants to know what is the volume of this prism. This is from Lesson 76. So to find the volume, you had to find the area of the base and then multiply that by the height. So in the previous problem, we already determined that this right here is our base, this triangle. So if this triangle is our base and this is the other triangle is like the top, then that means this is our height. So the height is always the perpendicular line between the two bases. So 11 is our height. So to find the area of the base, we can see that it's a triangle. So the formula is base times height divided by 2 and then multiply that by height. So our base, I'm going to write it over here. Our base is 4. The height of the triangle is 3. I divide that by 2 and then multiply by 11. So on the left, 4 times 3 divided by 2, that's 12 divided by 2 is 6, times 11 will give us 66 centimeters in its volume, so always cubed. Number 9, we need to simplify. So we have 5a cubed b minus 3a to the 4th b a to the negative first. All right, the first thing I notice is a to the 4th here and a to the negative 1 here. And notice this is one term here. So I can combine these two a's on this side. I wouldn't combine it with this a over here because they're two separate terms. So right now we're not going to worry about the term right here. Let's just focus on this a to the 4th and a to the negative 1. They're being multiplied together. So if you remember our exponent rules, when we multiply, we add our exponents. So that's really 4 plus a negative 1, which is a positive 3. So let's go rewrite all this as 5a cubed b minus 3. We now have a to the 3rd since we combined these two and got a to the 3rd. And then we just have b. So now these are like terms. They're both a cubed b. So remember when we have like terms and we're adding and subtracting, all we do is combine our coefficients. And we keep the variables the same. So 5 minus 3 will give us 2, a cubed b. And there's your answer. Number 10 is from lesson 50 and 79, solve for x. First thing you want to do is when you see these parentheses, you want to clear those by using your distributive property. So we need to distribute that 2 in. So we get 2x plus 4 equals x minus 8. Now we want to get our x's all on one side. So you could either move the 2x over here and get your x's all on the right, or you could move this x over to here and get your x's all on the left. Either way, you should get the same exact answer. It's just what your preference is. I would rather subtract this x from the right and subtract the x from over here, because then I won't have to deal with any negative numbers. So once we subtract that, these cancel, and we just have negative 8 on the right side. On the left, we have 2x minus x, and there's really a 1 right there, so that just leaves us with x plus 4. And now we want to get rid of this 4, and we're going to do that by subtracting it, because that's the opposite of the addition. And it cancels on this side, but we have to keep our equations balanced, so we subtract it from that side, from the right side. On the left, we're left with x, and on the right, we have negative 8 minus 4. So sometimes it's a little hard to see what exactly we're doing when it's written vertically. So for some of you, it might help to write it out, negative 8 minus 4. And then see at this point, you could do your add a line, change a sign. So it's really a negative 8 plus a negative 4, which will give you a negative 12. And that is your final answer. And you can always check your answer by taking this negative 12 and plugging it back into these x's and making sure that that works out and gives you a correct answer. Number 11 comes from lesson 80, and they want us to subtract. So when you're subtracting, just like you would a regular subtraction problem, we're going to start over on the right side. So we have 2 inches minus 6 inches. Well, you can't do that because 6 is more than 2 inches, and we can't have a negative number of inches. So when you have a problem like this, we need to go and, just like we would a subtraction problem, borrow from our feet. So I'm going to take away one of these feet, so now I have 0 feet, and I'm going to give it over to these inches. Now I'm not just going to give a foot over, I have to convert it back to the inches. So we know 1 foot is 12 inches. So I'm really giving 12 inches over to the 2 inches I already have. So I now have 14 inches. And now I can easily subtract 14 minus 6 will give me 8 inches. But now we have 0 feet minus 1 foot, which again we can't do. So we have to go and borrow from the left. So we're going to take away one of these yards, so there's going to be 2 yards left, and I'm going to give it over to these feet. So we know 1 yard is equal to 3 feet. So instead of converting 1 yard over, I make it as feet, and I bring over 3 feet and add it to the 0, so it's just 3 feet. So 3 minus 1 will give me 2 feet. And then the yards, 2 minus 1 yard is 1 yard. Number 12 is from lesson 77. We have to solve and graph. So these problems are very similar to solving equations, but we just have an inequality sign. So already looking at this, because this is just a plain less than sign, I already know we're going to have an open circle when we graph this. So let's solve this like we would a normal equation. We start off, we have negative 3 times x. So to undo that multiplication, we divide. We're going to divide by that negative 3. So then those cancel. But just like an equation, we have to keep this balanced, so we divide this side by negative 3. And we get x. Now notice we divided by a negative number. Anytime you divide or multiply across the inequality by a negative number, you have to flip the sign. So we flip the sign, and we get 9 divided by negative 3 is negative 3. Now let's go graph this. You usually like to always have 0 in the middle, do a few numbers out to the right, and then a few numbers to the left too. So this is saying x is greater than negative 3. So you always want to take this number, and that's where you either put the open or closed circle. So in this case, it's going to be an open circle. and I have x is greater than -3. So that means any number greater than -3 will solve this inequality. So that means all of these numbers, and you want to put an arrow to show that it's continuing forever. You can also look at your inequality sign as a hint. Notice that it looks like an arrow pointing to the right, just like this one. So that'll kind of give you a clue on which way you need to be graphing. Right, number 13, lesson 63. There are 18 girls and 6 boys in the class. What percent are girls? So for these problems, I first like to find the fraction. We know that there are 18 girls, but in order to find the fraction of girls to the whole class, we need to figure out how many kids are in the whole class. So if there's 18 girls and 6 boys, that means there's a total of 24 students. So 18 over 24 is the fraction of how many girls are in the class. I'm going to reduce that, divide both by 6, and get 3/4 because that'll just make this a little bit easier. And then I need to turn this into a percent. Well, 3/4 I already know is 0.75. And then if you move your decimal over twice to the right, that'll give you 75%. But if you got a problem and you didn't immediately know what the fraction was as a decimal, then to quickly turn this into a percent, you could divide and turn it into a decimal, or you could just take your fraction, multiply it by 100% over 1, and that would give you 300% over 4, and then you just needed to divide. So let's go over here, and I'll do 300 divided by 4, and that'll give me my 75%. Number 14, lesson 56, graph the following equation, y equals -x plus 2. Fortunately, this is already written in our slope-intercept form, which is y equals mx plus b, where m is our slope and b is our y-intercept. So we always want to start with our y-intercept. So that is a +2. So we're first going to go and put a dot on +2. And then we need to look at our slope. Our slope is the number in front of x. So if we have -x, that's really a -1 over x. And remember, slope is always rise over the run. So if you have a whole number like -1, if it helps you, you can just put it over 1. So since our rise is a negative number, that means we're actually going down. So down 1 over 1, down 1 over 1. So we're going to go down 1 over 1, put a dot there. And then we can do another one and go down 1 over 1 and put another dot there. And then go down 1 over 1, down 1 over 1. And then I'll try my best to make that a straight line and connect all those points. And then draw your arrows on both sides showing it extends in both directions. Number 15 comes from lesson 67. If the sales tax is 8.5%, what is the total cost including tax of an item priced at $30.10? So whenever you're trying to find the tax or a sales price, you're always multiplying. You're multiplying the money times the percent of the sales tax. So you're trying to figure out what is 8.5% of $30.10. And we know of means to multiply in math. So we never want to multiply by a percent. So we're going to change that 8.5% into a decimal. And we do that by moving our decimal 2 places to the left. So now we have 0.85 times $30.10. It gives us 2.5585. Now this is supposed to be money because this is how much tax there is. So we don't have our money written out 4 decimal places. So we need to round that to the nearest cent. So we're going to say the tax is then about $2.56. But we're not done yet because they want to know the total cost, including the tax. So therefore, we have to go back to our original bill, which was $30.10, and then add on to it our tax. So that's going to give us 66, 2, and 3. So $32.66 is going to be the total cost. Number 16, the vertices of a trapezoid are -4, -4, 4, -4, 2, 2, and -2, 2. What is the area? That should say area right there. Of the trapezoid. This comes from lesson 75. So first thing we want to do is go plot those points. So -4, -4 is going to be right here. +4, -4 is over here. So that looks like that's our base. And then we have 2, 2, which is right here. And -2, 2, which is over here. And there's our top one. And then we'll just connect those and you can see you have a trapezoid. So we need to find the area of the trapezoid. So remember, area equals 1/2 base 1 plus base 2 times the height. So first I need to figure out how long my two bases are. So if we look over here, starting right at this point, to go from this point all the way over here, you have to go over 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. So we'll go plug that in for our base 1. We have 1/2. And now we need to go find our base 2. So we'll go find the top. So again, going from this corner over to this corner, there's 1, 2, 3, 4. So that's 4. And now we need to look at the height. So going from the very top to the very bottom. That's 1, 2, 3, 4, 5, 6. And now we just follow our order of operations. So we have 1/2, do our parentheses, which is 12 times 6. 1/2 of 12 is 6 times 6. So your answer is 36. We don't know if it's inches or centimeters, so we're just going to say units. And since it's area, it's squared. Number 17 is from lesson 73. It says a formula for the following sequence is A subscript n equals n parentheses n plus 2 times 2. And then it gives you about the first 4 terms of the sequence. They want to know what the 20th term is. So for these problems, all you need to do is plug in 20 for where you see an n. So this is just telling us we're finding the 20th term. I'm going to plug in a 20 for this n, for the second n. And now we do our order of operations. So we have 20 times 22 times 2. And then go from left to right. We'll do 20 times 22 is 440 times 2 will be 880. So our 20th term is 880. Number 18, we need to solve for x. So this is a little similar to a problem we already did. Again, we want to distribute the 4 into the parentheses, so we get rid of those parentheses. So we have 4x plus 12 equals x minus 9. And we want to get all of our x's onto one side of the equation. We have 2 x's though, so we could either move the x to the left or the 4x to the right. I am going to move this x over to the left. So since that's just a positive x, if I subtract it from itself, it'll get rid of it. But then whatever I do to the right side, I have to do to the left. And remember, there's really a 1 in front of there. So 4x minus 1x is 3x plus 12 equals minus 9 or negative 9. Now I need to get rid of the 12. So since it's plus 12, I'm going to subtract 12 so that they cancel, and then subtract 12 from this side. So I'm left with 3x on the left equals a negative 9 minus 12. So again, if it helps you, write it out. So you can see that you're doing the add a line, change the sign. So a negative 9 and a negative 12 is a negative 21. And now we need to undo that multiplication by dividing by 3. So those cancel and we get x equals negative 7. Number 19 comes from lesson 80 and they just want us to add. So 45 plus 20 seconds is going to give us 65 seconds. 20 plus 45 will give us again 65 minutes. And then this is 3 hours. But then we have to go and start over here on the right. 65 seconds, we know there's a minute in there because a minute is 60 seconds. So we're going to take that minute out and give it over to the minutes so that there's only 5 seconds left. And now this 65 plus the 1 minute we took from the seconds will give us 66 minutes. And then we still have our 3 hours. But now we have a problem here because 60 minutes makes an hour and this is over that. So we're going to pull 1 hour out of there and give it to our hours. And we'll have 6 minutes left over. And we have the 5 seconds over here. And now we have 4 hours. And that's it. Number 20 is from lesson 78, and they want us to simplify. So 2 ways you could do this. You could do 12 times 32, which would give us the square root of 352. And then start breaking that up into its prime factors. But that's a pretty big number, and I don't know a lot of the factors off the top of my head. So there's another way we could do this, which might be a little easier. And that is we break down these separately into their prime factors. So let's start with 12. 12 we can break down into 4 times 3. 3 is prime, so I'll circle it. And 4 into 2 and 2. 32 I'll break down into 8 times 4. 4 breaks down into 2 and 2. 8 I can break down into 4 and 2. And then 4 into 2 and 2. And now I'm going to make one really long radical sign. And I'm going to multiply all of these prime factors together and put them underneath the radical sign. So first I'm going to put all the 2's because I'm going to put them in order from least to greatest. So we have 1, 2, 3, 4, 5, 6, 7 2's. 1, 2, 3, 4, 5, 6, 7. And then we have 1, 3. Then we go through and look for our pairs. So here's a pair of 2's, another one, and another one. So remember, we can only pull pairs out. So we pull out a 2 to represent that pair. We're going to pull out another 2. Remember, we multiply them when we pull them out. And then we pull out the third 2 to represent that third pair of 2's. And then these 2, the 2 and the 3, don't have a pair, so they have to stay inside. So now we just need to simplify. On the outside, 2 times 2 times 2 will give us 8. And on the inside, 2 times 3 is 6. And that is our final answer.